Good day, student. Here we are going to take a look at the design of differential band brake. A question says that a differential band brake shown below has angle of contact 225 degree. The band has a compressed woven lining and bears against a cast iron drum 350 millimeter diameter. The brake is to sustain a torque of 350 Newton meter and the coefficient of friction between the band and the brake drum is 0.3. We are to find question number 1, the necessary force P for the clockwise and anti-clockwise rotation of the drum. Question number 2, the value of OA for the brake to be self-lock when the drum rotates clockwise. Now let us start. Solution. Now let us look at our given. Now what are we given? We are given the contact angle theta to be equal to 225 degree to radian by multiplying it by pi over 180. This will be 225 multiplied by pi over 180, and this gives 3.93 radian. Then we are also given the diameter of the drum D, which is equal to 350 mm. Then from there, we get the radius as half of the diameter, which is equal to 175 mm. Then also, we are given the torque transmitted, T, which is equal to 350 Newton meter, which is the same thing as 350 times 10 raised to power 3 Newton millimeter. And again, we are given the coefficient of friction to be equal to 0.3. Now, let us start the journey. We know that, okay, the first question is we have to calculate the force necessary for the clockwise and anti-clockwise rotation. So, the force P necessary for the clockwise and anti-clockwise rotation of the drum. Now from here, let us apply the relationship between the tension on the tight side and slack side. First of all, let's analyze this circuit. When the drum rotates in the clockwise manner, if the drum rotates in the clockwise manner like this, then the band that is attached to B will be in tension, while the one that is attached to A will be under slack. Therefore, T1 will be on the side B, while T2 will be on the side A. And when it rotates in anti-clockwise direction, T1 will be on the side A, while T2 will be on the side B. Now, let us now apply the relationship between the two tensions. We all know that we have 2.3 log T1 over T2 is equal to mu theta, which is equal to, our mu is 0.3, our theta is 3.93, and when we evaluate this, we are going to get 1.179. That is to say, 2.3 log T1 over T2 is equal to 1.179. Let us divide both sides by 2.3, then we'll have log T1 over T2 is equal to 1.179 divided by 2.3. 3, and in doing so, this one gives 0.5126. That is log T1 over T2 is equal to 0.5126. The next thing is we take antilog of both sides. We take antilog of both sides. When we take the antilog of log T1 over T2, it will give us T1 over T2. Then when we take the antilog of 0.5126, it will give us 3.256. Now let us call this one equation 1. Then we know that the breaking torque T is equal to T1 minus T2 multiplied by the radius of the drum. From here, when we substitute, we have 350 times 10 raised to power 3 is equal to T1 minus T2 multiplied by the radius of the drum, which is equal to 175. Then from here, we have T1 minus T2 is equal to 350 multiplied times 10 raised to power 3 divide 175. We have T1 minus T2 is equal to 2000. So let's call this one equation 2. Now, solving equation 1 and 2, then we'll get our tension T1 to be 2886.5 Newton, and our T2 to be equal to 886.5 Newton. Now, what next here now is that we are going to take moment about the fulcrum O. Now, taking moment about the fulcrum O for clockwise rotation. Now, when we do that for clockwise rotation, then we have P that generates clockwise moment and T1 generates clockwise moment. Then T2 will generate anti-clockwise moment. For that, say P times 500 plus T1 times 35 is equal to T2 times 150. Then we have P, we have 500P is equal to 150 T2 minus 35 T1. When we substitute the value of our T1 and T2, we have 500P is equal to 150 times our T2 is equal to 886.5 minus 35 times our T1 is equal to 2886.5. And when we do this, we have 500P is equal to, when we carry out this evaluation, we are going to have 31,947.5. We divide both sides by 500. P will be equal to 31,947.5 divided by 500. And this will give the value of P as 64 Newton. This is the value of P for the clockwise rotation. Now, let us take a moment about the fulcrum for the anti-clockwise rotation. So taking moment about the fulcrum O for anti-clockwise rotation. At that point, we have P generating clockwise movement and T2 also generating clockwise movement, while T1 generating anti-clockwise movement. Then for that, we have P multiplied by 500 plus T2 multiplied by 35 is equal to T1 multiplied by 150. Then we'll have 500 P is equal to 150 T1 minus 35 T2. Then when we substitute the value of T1 and T2, we have 500 P is equal to 150 multiplied by the value of T1 is 2886.5 minus 35 multiply the value of T1 which is 886.5. Then we have 500 P is equal to 401,947.5. We divide both sides by 500 to get P. P is equal to 401,947.5 divide by 500, which gives 804 Newton. This is the value of P when it rotates in anti-clockwise manner. That is the first part of the question. The second part of the question, we have to find the value of OA for the brake to be self-locking when the drum rotates clockwise. Value of OA for the brake to be self-locking for the clockwise rotation. We all know that self-locking is a phenomenon that is associated with clockwise rotation. Now here, what we need to do here is also take moment about the fulcrum for the clockwise rotation. So taking moment about the fulcrum O for the clockwise rotation. Now, in doing so, we have P multiply 500 is equal to T1 multiplied by OB minus T2 multiplied by OA. From here, for self-locking to take place, P has to be either negative or 0. And let us consider P to be 0. And the only condition for P to be 0 here is when T1 multiplied by OB is exactly equal to T2 multiplied by OA, so that when they subtract from each other, it becomes 0. So for P to be self-locking, then T1 multiply OB must be equal to T2 multiply OA. And we're looking for OA, then we make OA the subject of the formula. We have OA is equal to T1 multiply OB divide T2. Then when we substitute the value, we have 2886.5 times OB, which is 35, divide T2, which is 886.5. When you press your calculator, when we evaluate this, OA will be equal to 114 millimeter. Thank you very much for being patient with us.